Hi, I'm Nick and I'm a software developer at Voltron Data and I'm also one of the Apache Arrow maintainers. I work mainly on the R package and that's going to be the focus of my talk today. If I were to summarise my talk into a single idea that I'd like you to take away from it, it would be that as a user of the Arrow R package, no matter what your level of R experience or amount of time that you've got to spare, there are ways of getting involved with and contributing to the package that will benefit both you and the project yourself. So today I'm going to start off by talking about different ways of getting involved which involve non-code contributions, and then I'm going to move on to talk about contributing code. But actually, before I start, I just want to mention the new contributors guide. So this is an initiative championed by Lenka Frim and it's now part of the project documentation. So I'll provide everything I mentioned today, I'm going to provide links to at the end of the talk. So in the new contributors guide, there's all sorts of information like where to find issues currently being worked on, how to get help with different aspects of the project, and things like a step-by-step guide to fixing an issue and submitting a pull request, both in R and in Python. Alenka's going to be giving a talk herself about the topic, so you should definitely check that out as well. So there's lots of different ways of getting involved with the Arrow R package, and actually some of the most helpful contributions don't involve writing a single line of code. So I'm going to start off by talking about ways of contributing that don't actually involve making a pull request necessarily. So project documentation is really important to help users make best use of a package and understand how things work. Enhancing the project documentation is a really great way to get involved. And actually, if you're somebody that's used the Arrow R package but hasn't actually had an in-depth involvement in its development, you're actually at an advantage in terms of writing documentation here. So let me just explain that in a bit more detail. So there's a cognitive bias, you might have already heard of this, called the curse of knowledge. And what it boils down to is the more that you know about a topic, the more assumptions that you unintentionally make about the information other people have access to make sense of that topic. So what that actually means is it's really easy for people with in-depth knowledge of something that have been working on it for a long time to end up with blind spots when communicating about it. And so something that seems really obvious to an existing maintainer actually might not be at all obvious to a new user. And this can come out in documentation. So just sort of using a jigsaw as a metaphor, I might write some documentation that I think I've explained a new feature and it looks like this completed jigsaw puzzle. Actually, what I've done is provide you with something that looks more like this. So kind of some of the pieces are there and my mind can kind of fill in the blanks because I've seen it so many times before. But actually, if you're someone that's never come across this, you're going to have a really hard time kind of figuring out what the other pieces look like here. Or it could be something like this. So I've provided all of the pieces and they just need rearranging to be a bit more understandable and to make sense. Or even something more like this. So it's pretty close and it just needs a little nudging and moving around to make everything link together nicely. So I wanted to actually kind of make this more concrete and give you a few examples of helpful documentation updates we've merged recently. So first, this is one where a contributor has added some code examples to the documentation for a certain function, just to make a concept more clear. And that was really great. And then here's another one. So I think a section of explanation's been moved and some markup's been edited just so that the automatic linking between different bits of documentation works a bit better. So even though these are quite kind of small in terms of the amount of changes that are made, this has been really helpful. So yeah, so if you're a user and you spot some documentation that doesn't explain things particularly clearly, or maybe doesn't make sense, we'd love to hear from you. So whether that's reporting it as an issue on the project Jira, or making the change yourself, that's fine. Documentation is super important, and this is a really great place where you can make a real impact. So again, this could be anything from adding more examples to function documentation to working on project vignettes. And as a colleague said to me the other day, like you're only new once, right? And that is like a perfect time to be able to notice these things. Okay. So another way of getting involved is getting involved with the cookbook. So the Arrow cookbook, it's a collection of recipes for getting different tasks done with Arrow. And the R version of the cookbook is another place that you can get involved. So I'm just going to go through a little bit about what the cookbook is and what it looks like. Okay, so the aim of the cookbook is to provide recipes, that's short, reproducible code snippets that users can run, and it just shows them how to get a specific task done in Arrow. So if we look at the sidebar, we can kind of see there's all sorts of recipes for different things. So whether that's creating arrow objects, defining data types, manipulating data, and loads more different topics. So I'm just going to go through an example from the cookbook. So this is an example recipe, and it shows users how to change the data type of an arrow array. And actually, when we're writing these recipes, they've all got a pretty standard format. So I'm just going to go through those one at a time. So we start off with the recipe name at the top. So here, update data type of an existing arrow array, and then a short description of the behaviour that we're trying to show. So we then show the code recipe, so that's the code that we need to solve the problem, and the output as well, just to really tie things together. And sometimes, but not always, it's followed by an optional discussion section. So we talk about things that won't work with the recipes maybe, or provide further context. So in the example here, we talk about what happens if you try to change between incompatible data types. But there could be all sorts of things in the discussion section, just for kind of extra reading, extra context, extra information. So if you've got any requests for recipes you'd like to see in the cookbook, or suggestions for updates to existing recipes, or maybe you've even got recipes of your own from your own workflow that you'd like to contribute, in this case, please open an issue on the cookbook and let's discuss it there. Just to point out here, so in terms of the main Arrow code base itself, we actually use Jira to track issues, where in terms of the cookbook, we use GitHub issues. So it'll be at the link there. And again, I'll provide all of the links at the end of the talk. Okay, so Arrow's features keep growing, and one thing actually that I'd love more sight of certainly is how people are actually using Arrow in real life. So if you use the Arrow R package as part of a workflow, and there's something that you can want to do as part of your workflow but you can't do it in Arrow, and you think it'd make a good feature addition, again, please do open a ticket on the project Jira, because that would be really great to see as well. So another way of getting involved is opening bug reports. So as much as every time we implement a new feature, we write unit tests and things, there's always going to be some weird edge case, some weird clash between maybe another library, or just something that can go wrong. And it's really useful when that happens to get bug reports so we can see those things. Now, even if you're not sure if something's a bug or not, I'd really encourage you to just open a bug report anyway. Because sometimes when something isn't a bug, it can indicate there's something else going wrong if it prompts somebody to open a bug report. So it might mean actually we want to update our documentation or something else. So let me show you an example of that. Okay, so here's a bug report. This is just from the project Jira. This was actually really helpful. So the user opened this bug report, and actually the behaviour that they found, it wasn't a bug, it was more of a misunderstanding. But it was kind of fair play that they did find this behaviour confusing. And actually, there wasn't a huge amount of information when things did go wrong about what was the cause of the issue. So here's a bit of a snippet of some of the code that was changed as a result of this. So what happens in this case now is when the same behaviour is replicated, we get this little error message that just basically says, if you've supplied a schema and your data contains a header row, you should supply the argument skip equals 1 to prevent the header being read in as data. Now, I know that won't make much sense without the context within which it is, but the point that I'm wanting to make here is this has helped us improve our user experience, and even though it wasn't a bug, it was definitely worth reporting. I know for me personally sometimes I find it easy to fall into that trap of thinking that if I've read the documentation and the code isn't working, I should just understand it. But honestly, if it's still unclear at that point, you're probably not going to be the only person experiencing that. So yeah, I definitely encourage you to open a bug report. Okay, so that's all of the non-code contributions that I'm going to talk about. I mean, there are other ways of getting involved that don't involve contributing code. Even things like, if you use Arrow as part of a workflow and you've got something interesting going on and you want to blog about it, that's a great contribution as well, and I'd love to read that. But now I'm going to start to talk about code contributions. Before I get into it though, I'm going to say the setup for the Arrow R package is a little bit more involved than a typical R package. So first, I'm just going to give a bit of context about why that is and kind of how you can kind of get around, well, not get around that, but how you can get set up. So first, just to mention, the package down site, which contains the documentation for the Arrow R package, we've actually got a section, articles and then developers, of a load of different articles written to help kind of people that are contributing code to the project with different things that might be useful. You don't necessarily need to read all of these, but I definitely recommend checking them out. And the content that I'm going to be covering now actually is related to a lot of the content in those. Okay. So one of the guides in that section is the Developer Environment Setup Guide. And as I said before, if you've worked on other R packages, the Arrow R package might feel a little bit different. But really, there's just a few extra steps that you need to kind of follow before being able to follow a typical R package development workflow. So this is just because typically, if you're working on an R package that contains just R code, you've got a folder containing your code and you can work with that. But because the Arrow R package is built on top of the Arrow C++ library, also known as libarrow, it means that we need to think of both of these things at the same time. And the reason for that is if you've got a brand new version of the Arrow R package code, but some really, really old version of libarrow, they're not going to be compatible with each other and you're going to get all sorts of weird error messages. So we just need to make sure that we're using kind of compatible versions of the two. So this is all in that Developer Environment Setup Guide, but just to kind of show you, there's two different ways of doing it. The first one, if you want to make a change to the R code, but not to libarrow, that's the C++ itself, you can get the latest version of the R package from the Arrow GitHub repository, and then you can install a binary version of libarrow from our nightly builds. This is going to be the latest version of libarrow from the previous evening, and it being a binary means that it's already compiled and ready to use on your system. And again, there are instructions in the Developer Setup Guide that tell you the steps that you need to follow to do this depending on your specific operating system. Alternatively though, you might want to make a change that maybe involves updating libarrow itself, and therefore you might want a libarrow build with certain kind of optional features enabled, or even that you don't, even like the last night's nightly build isn't recent enough. If you've got a change that you want to, like that's gone in kind of in the past few hours, that you want to make a change on the basis of that. So in that case, you want to build libarrow from source. This might sound complicated if you've not worked with C++ or compiled code before, but it's just repeatable steps to follow, and the instructions are in the Developer Environment Setup Guide. I will say, like, as somebody that had never worked with C++ before getting involved with Arrow, I do admit, like, it did feel a bit intimidating at first, but once everything's set up, it then became kind of repeatable steps to follow. And just in case you've got any issues getting set up, there's instructions in the setup guide on troubleshooting different potential things that could happen. But if you are getting set up and you've got any issues, please do feel free to email kind of the dev mailing list or open an issue on the project repo, and somebody will kind of take a look at that and help you. Okay, so now I'm going to talk about the kind of code that you could get involved with contributing. So actually, one of the simplest contributions you could make is a test. So if you find like a bug or a weird edge case that causes unexpected behaviour, you could open up a pull request with a unit test that fails, and that's a really great way of illustrating what's happening there. But alternatively, you might have a specific issue or feature that you want to work on. And if this is the case, there's a really, really great step-by-step guide for how to do that in the New Contributors Guide. And again, Alenka Frim's presenting about that, so I'm going to leave that content for her talk, and instead here I'm going to talk about some more of the technical details of the internals of the R package itself. So, as I mentioned before, the Arrow R package is built on top of the Arrow C++ implementation. One of the great things about this is in the R package, there's a certain bit of functionality where you can run dplyr code. And you can use the dplyr API, dplyr syntax, to write code, which then runs on the Arrow backend, also known as Acero. So when we talk about this machinery in the Arrow R package that makes this all work, we call these bindings, because you're basically tying together the dplyr code with the Acero code. So in the next section, I'm going to talk a little bit more about that, and also about how you could contribute bindings to Arrow. So just to kind of reiterate the previous kind of point about the dplyr code and the Acero code working together and give it a bit more context. If you've ever used the dplyr package in R, you're using the dplyr API, and that runs code on the dplyr engine, the dplyr backend. If you've ever seen the package dbplyr, that allows you to take the same dplyr code but then run that on a SQL database. So Arrow is kind of similar in certain ways, the Arrow R package, in that it allows you to take that dplyr code but then run it on Acero, so that's the Arrow engine. Okay, but the code for Acero, that's written in C++, and we just need to write some code to bridge that gap between the sort of the dplyr code and the Acero backend to get it working as we expect. So just to illustrate kind of the results of having done that, I've got a couple of code examples here. So on the left, it's an example where we're loading the dplyr library, and it's taking the Star Wars dataset. So that's a dataset that's got all the different characters from Star Wars in and information about them. We then just select the name column. We filter by only rows that start with the name Darth, and then we collect that data. So that just gets you 2 rows, Darth Vader and Darth Maul. Now, if we wanted to run that on Acero, there's not a huge number of code changes that actually need to be made. So on the example on the right, we load the dplyr package, we then load arrow, and actually the only change in that kind of chain of dplyr commands is that we just run this function arrow table, and it takes that Star Wars dataset and just converts it into an arrow table. And as we can see, we kind of run it exactly the same way as the other example. And when we collect that, we get the same results, but this time it's been run on Acero. And really, the reason that I'm mentioning this is that there's 2 aspects to writing these bindings. Firstly, there's a dplyr verb, so things like in this example, select and filter. And that's really interesting for some of the code that can get quite complex for that. But actually, the other aspect is writing bindings to the individual functions. So in this example, the function starts with, which basically just selects rows selects values that start with a particular kind of pattern. I'm going to just show you how the binding for that is written, because actually it doesn't take a huge amount of code to write that. Okay, so there's a lot of other things going on here, and I'm not going to go into detail about all of this, but just to show you that this is the code that's need to implement starts with. So basically what's happening here is the base R function, so that's the one on the top row, starts with, it's got parameters x and prefix, so x is the data to be looked at, and prefix is literally the text prefix, so in the example before it was Darth. And then there's an Acero function, very similar, but it's spelt starts _with, and instead of the parameter prefix, it's got a parameter called pattern. So this code here is creating the binding that says that when we're calling starts with in some dplyr chain that's using arrow, instead actually run this Acero function. And then the test for that as well, we've got some kind of code that we've already got set up to help make this simpler. So the function called compare dplyr binding, and what that does is it compares the output of running the code on the dplyr engine with the output of running on Acero and make sure it matches. Again, this is stuff that you'd have to go into, just like look into a bit more to get it working. But the point here I just wanted to show you is that it can take very little code to write these bindings. So if there's a base R or tidyverse function that you would like to use in an arrow dplyr kind of pipeline and it's not got bindings yet, it could be something that you could contribute. Now, there's a guide to writing bindings as part of the developer documentation, and that goes through what I've just mentioned, but in a lot more detail. It takes it down step by step. So I definitely recommend checking that out if you're interested in that. Okay. So, thanks for listening. I've got some links here relating to some of the things that I've been talking about, so some useful links to navigating your way around the project. And just as a final summary, so there's lots of different ways you could get involved in contributing to the Arrow R package, and contributions absolutely do not have to involve code. And we welcome new contributors and hope to see you getting involved.